Hello and greetings to everyone. We are going to start with topic 2, denoted as T subscript 2, the set of natural numbers. When we talk of set of natural numbers, we think of the set of countable numbers. We make good use of this set of numbers in our day-to-day life, in the buying and selling of items, in the counting of objects, in computer programming, in the measurement of certain physical quantities like time, in the recording of scores in games, and in communicating our telephone numbers. Also, we make good use of these numbers in the production of mathematical numbers for cars. So after this lesson, I believe each and every one of you watching will be able to answer the following questions. The first one says, what is a natural number? It is the first star. The second star, 2 star, says, what is a number line? Then 3 star, how to compare natural numbers. First, I will start by defining a set. When we talk of a set is a collection of well-defined objects. When we talk of well-defined objects, that means the objects, they share a particular characteristic in common. For example, we can talk of let's write, for example, a set of vowels. We have a set of even numbers. You can see in this case a set of even numbers, that is all those numbers that can be divided by 2. Next, let's give another example. A set of boys. And let's give a last example. A set of college students. These are all examples of sets. Next, we call the members of a set, we call each member of a set an element. We call the member of a set an, I'll write it down with a red pen, an element. Next, when writing, it's very important, when writing the elements of a set, we enclose them by using curly brackets. using curly brackets. That is, we have the left and right curly brackets. That is, we have the left curly bracket, which is as such, and the right curly bracket, which is as such. Also, the elements of a set are separated by using a comma bracket. We use this symbol to separate the elements of a set. For example, let's write down some examples of sets. For example, I'll write down the first one. We stated here the set of vowels A, E, I, O, U. You can see the elements are enclosed by the curly bracket. Then we separate the elements by making use of the comma. And let me give another example. I'll write down some few even numbers: 2, 4, 6, 8, 10, 12. These are examples of sets. Next hyphen. When we talk of the set of natural numbers, we are simply referring to the set of positive whole numbers including 0. The set of natural numbers is the set of positive whole numbers. When we talk of whole numbers, that means those numbers in which the fractional part is 0. Positive whole numbers including 0. I'll underline this definition. It is very important. So you take note of this definition. So 0 is a natural number. The set of natural numbers is an infinite set. When we talk of an infinite set, that means a set that does not end. It does not have a last element. Next, the set of natural numbers is denoted by using the symbol. So when you see this symbol in brackets here, know that it is a set of natural numbers, or in other cases it is represented as such, or this symbol. So if you see any of them, it is for the set of natural numbers, something as such, or as such. Next, let's write down the elements of the set of natural numbers. That is Let's write it down. We have n is, we have first element 0, 1, 2, 3, 4, 5, 6, 7. We can end at 7. We end with 3 dots. These 3 dots, they simply mean that the elements of the set of natural numbers, they are endless. Let's write it down. The 3 dots, these 3 dots, let me put them in brackets. These are them. The 3 dots after the number 7 simply means and so on. Let me underline it. So you can start listing the elements of the set of natural numbers right up to 1 billion. The elements, they still continue. Then in brackets, the numbers are continuous to the right. Next, we denote the set of natural numbers excluding 0 by making use of n star. So when you see something like this, n star, n with a star above as such, it simply represents the set of natural numbers, and you remove the element 0 from it. Take note of this. That is, you have n star. The first element of n star is 1, 2, 3, 5, 6, 7, 8. It's also an endless set. So you see that all the elements of n star are elements of n. Therefore, n star is a subset of n. N star is the subset of n. That is, because all the elements of n star, they are found in n, but n star does not have 0. This funny C you see, like this, which is pointed, it simply stands for is a subset of n star is a subset of n. Take note of this. Next, take the next hyphen. To write mathematically, you know mathematics is a language. To write mathematically that an element belongs an element belongs to, you underline it, belongs to, or does not belongs to, does not belongs to a set of natural numbers, we make good use of the following symbols. We make use of the following symbols. I'll write down the symbols. The first one, it looks like an E as such. This one stands for belongs to, or is an element. Is an element of. Then the next symbol we have, it looks like the first one, but with a slash over it as such. This one stands for does not belong to, does not belongs to, or is not an element of. It's not an element of. Next, let's write down some few examples. E.g., stands for example given. 0 is an element of the set of natural numbers. We are going to make use of this. Writing it mathematically, we have 0 belongs to the set of natural numbers. 28 belongs to the set of natural numbers. Negative 15 does not belong to the set of natural numbers. 0.91 does not belong to the set of natural numbers. 1845 belongs to the set of natural numbers. So these are some few examples. Next, let's take down the next thing, which is the number line. The number line. It's a small heading. When we talk of a number line, this is a straight line. Let me write it down. This is a straight line having numbers. Time is finished. Having numbers placed at equal intervals along its length. The number line for the set of natural numbers starts from 0. You can see here 0 is the first element for the set of natural numbers, so it starts from 0 and ends with an arrow. The arrow simply indicates that the set of natural numbers is endless towards the right hand side. That is, let's draw a number line. Luckily, my ruler is scaled, so I'll use a scale of 1 centimeters. Start from the 0 mark. So, making use of a scale of 1 centimeters. Since we cannot write out all the elements on the number line, we are going to put this arrow towards the right, indicating that the numbers continue towards that direction. The first element, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yes, we can end at 14. So you take note, the arrow on the number line, let me write it down. The arrow on the right hand side of the number line simply this paper is full, simply indicates that the numbers continue towards the right. We know they are infinite, so I'll write infinite in brackets. By using the number line, it's very easy for us to compare natural numbers by using the number line. It is very easy for us to compare any given natural numbers. As you can see, on the number line, as we move from the left hand side to the right hand side, the numbers increase in size. For example, if we are to compare, let's take for example, we are to compare the numbers 5 and 11. You will see that 5 is to the left hand side of 11. In such a case, we are going to say 5 is less than 11, or 11 is greater than 5. You take note. Now let's take for example all numbers to the left of 5 are less than 5. I'll underline less than. and all numbers to the right of 5 are greater that means bigger, greater than 5. Underline greater than. Take note. Next, when comparing numbers, we make use of the following symbols. Let me write this down. When comparing numbers, we make use of the symbols below. There's a symbol for less than. It looks like a V, which is sleeping and facing the left hand side. So this symbol stands for less than. And we have this other symbol which looks like a V, which is sleeping and facing the right. Stands for This one stands for greater than. Greater than. Now let's take, for example, most often I love working in a general case. Let's take generally. Let's say generally, if A and B are two natural numbers. Mathematically, this is how we write it: AB belonging to the set of natural numbers. Then we can have the following. We can have the following. We have the following possible outcomes. The first one, we can have A is less than B. That means A is to the left hand side of B on the number line. Or the next possible outcome, we can have A is greater than B. That means A is to the right hand side of B. Or the third possible outcome, or A is equal to B. That means they are the same. We know A less than B is the same as B greater than A. A less than B is the same as B greater than A. We know A greater than B is the same as B less than A. You take note. This pair represent the same. This pair represent the same thing. Next, let's take some examples on this. Example. Let's take question 1. Question 1. Use the symbol belongs to, does not belong to complete the empty spaces below. A, we have the number 27, the empty space, set of natural numbers. B, we have 1.3, empty space, set of natural numbers. C, we have negative 201, empty space, set of natural numbers. Z, we have the number 1 million. Let's take this number 1 million and 37,815. The empty space, set of natural numbers. Then question 2, use the symbol less than or greater than to complete the empty spaces below. The first one, A, we have 15, empty space 13. B, we have 734, empty space 836. C, we have 100/10, empty space 31. D, we have 15/3, empty space 124/2. We have to answer these questions. Next, we are going to take now the solution. Let's proceed to the solution. Question 1. It says that we should use the symbol. We have to use this symbol belongs to or does not belong to complete the empty spaces below. For the first question, A, we have 27. We have 27. The empty space, set of natural numbers. First, if we look at our number line, this is the number line. You'll see that if we extend this number line, we are going to meet the number 27. 27 is at the right hand side. So 27 is an element of the set of natural numbers. 27 is a positive whole number. So in this case, we are going to make use of the symbol belongs to. We take B. B, we have the number 1.3, the empty space, the set of natural numbers. 1.3 is a positive number. It has a fractional part, the 0.3, so it is not a whole number. In this case, we are going to make use of the symbol does not belong to. For C, we have the number negative 201, the empty space, the set of natural numbers. This number is a negative whole number, so it does not belong to the set of natural numbers. For D, we have the number 1 million and 37,846. For D, we have the number 10,037,815. We have the empty space, set natural numbers. Next, we know this number is a positive whole number, therefore it belongs to the set of natural numbers. Question 2 says we should use the symbol less than or greater than to complete the empty space. So for the first one, A, we have the number 15, then empty space 13. So if we draw our number line, look at our number line, we know 13 is to the left hand side of 15. If we are to continue, we are going to meet 15. So in this case, 15 is greater than 13. We are going to make use of greater than. For B, we have the numbers 734 and 836. We have these two numbers. You know 734 is less than 836. Because on the number line, 734 is to the left of 836. So we are going to make use of this first symbol, less than. For C, we have the number 100 over 10. We have to simplify. 100 divided by 10 will give us 10. Then we have the empty space. We have the number 31. We know 10 is to the left hand side of 31, so 10 is less than 31. D, we have the number 15 all over 3. You know 15 divided by 3 will give us 5. We have the empty space. 124 divided by 2. We divide 124 by 2. This will give us 2 go here 6. 2 go here 2 times. So it gives us 62. If we compare 5 and 62, we know 5 is less than 62. So we can say therefore 15 over 3 is less than, I'll make use of these 3 dots, which stands for therefore is less than 124 all over 2. So we are done with the correction of the example. We are going to end by taking down these exercises for application. Make sure you answer the exercises. It's very, very important. So I'll give down these exercises for application. The first one, it says complete the empty spaces below by using belongs to or does not belong to. The first question, A, negative 25, empty space, set of natural numbers. B, pi, empty space, the set of natural numbers. C, 35 all over 10, empty space, set of natural numbers. D, we have 10,100 over 5, the empty space, the set of natural numbers. Then question 2 says complete the empty spaces below using less than or greater than or equal to. Question A, we have the number 241, the empty space 723 all over 3. Question B, 81 all over 3, the empty space 9 all over 3. C, we have 35, the empty space 77 all over 7. Lastly, for D, we have the number 100,124, the empty space 100,105. Let's do the number 105,000. So these are the exercises for application we have. You do well to answer the questions. In our next video, we are going to start by correcting these exercises, and the next thing we are to trade will be operations on natural numbers. Thank you very much for watching.